Your subject is Engineering Mathematics 3. In that, the first unit is linear differential equations with constant coefficients. Now, what is the actual concept of linear differential equations with constant coefficients? The general form of nth order linear differential equation with constant coefficient is a naught nth derivative of y with respect to x dn y by dx raised to n plus a2 dn minus 1y by dx raised to n minus 1 and so on up to an y is equal to f of x, where that a naught is not equal to 0, where a naught, a1, a2, a3 up to n are all constants and f of x is any function of x only. Now, we want the solution of this differential equation. It is linear differential equation with constant coefficients. It is linear because the degree of every term is 1 throughout, and it is the nth order differential equation because the highest order derivative term is here dn y by dx raised to n. So its order is n, but its degree is 1 throughout. So it is linear differential equation with constant coefficients. Now, how to find the solution for this differential equation? So first we have to reduce it. To reduce the differential equation, we use the substitution. Put d by dx is equal to d square by dx square is equal to d square, and so on. And so that we can reduce the differential equation like this: a naught d raised to n y plus a1 d raised to n minus 1 y plus a2 d raised to n minus 1 a2 d raised to n minus 2y plus up to and so on is equal to f of x. Now that y is common in every term, so take it common, and after taking y common, where the term like this, that bracket term is nothing but the expression in the form of d, means it is a it is a function of d into y is equal to f of x, and this bracket term is function of d, so we can write or replace the bracket term by phi of d because it is the function of d into y is equal to f of x. So here phi of d is equal to 0 is known as auxiliary equation. This expression phi of d, if we equate it equal to 0, it is an equation, and it is nothing but the equation called auxiliary equation. Now the the solution of the equation 1. So see, what is our equation 1? Equation 1 means phi of d into y is equal to f of x. This is the reduced form of LDE, and we are going to find the solution for this equation now. The solution of equation 1 involves two parts: complementary function as well as particular integral. So the general solution is nothing but y is equal to complementary function plus particular integral. It gives the complete solution of the linear differential equation with constant coefficients. So complementary now, the general solution is given by two parts: complementary function and particular integral. In that complementary function, now what is complementary function? The complementary function is the general solution of the homogeneous linear differential equation phi of d into y is equal to 0. Here the reduced form of LD is phi of d into y is equal to f of x. For a while you assume that this function is 0, and we have the equation phi of d into y is equal to 0. So we are going to find the solution for phi of d into y is equal to 0, and this solution will give you the complementary function. In a complementary function, the number of an arbitrary constants is equal to the order of the differential equation. Depending upon the nature of the roots of auxiliary equation, there are many types of complementary function is given below. There are different cases, means how to write the complementary function. It depends on the roots of the auxiliary equation. Auxiliary equation is nothing but phi of d is equal to, here we have mentioned what is auxiliary equation. In this reduced form, phi of d into y is equal to f of x. If phi of d is equal to 0, then it is known as auxiliary equation. So you find the roots of this equation, phi of d is equal to 0, and its roots of auxiliary equation, they are main means that roots of the equation, it gives the complementary function. Now there are different cases to write the complementary function. That first case is that type 1, case 1 is, suppose for that nth order linear differential equation with constant coefficient, suppose n number of roots are there, m1, m2, m3 up to mn are the roots, or and they all are distinct roots, real and distinct. They are real numbers and they are distinct roots. Then the complementary function for that uh, linear differential equation phi of d into y is equal to 0, it will be c1 e raised to m1x plus c2 e raised to m2x plus c3 e raised to m3x, so on up, plus cn e raised to mnx, because there are n number of roots and they all are real numbers and distinct. Distinct means different, and so its complementary function is like this. Now the second case is case 2. If d is equal to m1, m2, m3, these up to mn are the n number of roots, and in that n number of roots, suppose two roots are equal, m1 is equal to m2, and the remaining roots are real and distinct, then the complementary function is c1 plus c2x bracket complete to e raised to m1x plus c3 e raised to m3x plus up to cn e raised to mnx, means from c3 the remaining terms like the first case, case 1, and only two roots are equal, m1 is equal to m2, so there is the change here in first term c1 plus c2x, because two roots are equal, that's why the change is here. In case 2, if d is equal to m1, m2, m3 up to mn, these are the roots for the differential equation, because it is the nth order differential equation. This is case 3. And suppose three roots are equal, m1 is equal to m2 is equal to m3, and the remaining roots are real and distinct. They are real numbers and they are distinct means different. Then the complementary function is c1 plus c2x plus c3x square into e raised to m1x plus c4 e raised to m4x up to cn e raised to mnx. So this is case 3. Case 4, again, if d is equal to m1, m2, m3 up to mn, these are the n number of roots for the given linear differential equation with constant coefficient, and the order of the differential equation is n. And then that auxiliary equation has n number of roots, and in that n number of roots, suppose all roots are equal, m1 is equal to m2 is equal to m3 is equal to mn, and they are real numbers, they all are equal, and suppose they all are equal means there is a single root and the root is repeating n times and it is a real root, then how to write the complementary function? Then the complementary function is c1 plus c2x plus c3x square up to cn x raised to n minus 1 bracket complete into e raised to m1x. Here I am writing m1 because m1 is equal to m2 is equal to m3. They all are real roots. So here you can write m1 or m2 or m3, mn, because they all are equal means there is a single root and it is repeating n times. So this is the complementary function when all roots are equal. Now type 2, the second type, when if roots are complex and distinct, means suppose the differential equation is of order 2, so the differential equation, it has two roots and that roots are complex roots like this, d is equal to alpha plus minus I beta. The complex roots always occur in pairs. So now there are here complex roots are there, so there is a pair. It means there are two roots, alpha plus I beta, and second root is alpha minus I beta. Now complementary function for this alpha plus minus I beta, it is here in complex roots, alpha is the real part of complex number and beta is the imaginary part of complex number. So the complementary function for these complex roots is e raised to alpha x in bracket c1 cos beta x plus c2 sin beta x. This is the complementary function when the complex roots are there for the differential equation. If roots are complex and repeated, suppose the differential equation is of order 4 and the auxiliary equation has 4 roots, and that 4 roots, in that 4 roots, that complex roots are repeating. It means d is equal to alpha plus minus I beta is repeated twice, means alpha plus I beta is 2 times and alpha minus I beta is 2 times. Then how to write the complementary function? Then it is e raised to alpha x in bracket c1 plus c2x bracket completes cos beta x plus c3 plus c4x bracket complete into sin beta x. Like this, the case 1, here two roots are equal, so we write the term c1 plus c2x into e raised to m1x. Like this, here two complex roots are repeating. Complex roots always occur in pairs, means complex roots are repeated, means there are 4 roots, alpha plus I beta 2 times, alpha minus I beta 2 times, and so the term is c1 plus c2x cos beta x plus c3 plus c4x sin beta x. This term is because the complex roots are repeated twice here, and so this is the second type. In second type also there are two cases, case 1 and case 2. So these are the rules to find the complementary function. Now there is one note. If your auxiliary equation is a quadratic equation in the form of AD square plus BD plus C is equal to 0, it is a quadratic equation because its degree is 2. So how to find the factors for this quadratic equation? This is a auxiliary equation, phi of d is equal to 0. Quadratic equation. Then how to find the factors for this quadratic equation? The formula is d is equal to minus b plus minus under root b square minus 4ac upon 2a. This is the formula to find the roots of quadratic equation. The second note is for the cubic polynomial, apply the synthetic division after finding one real non-zero root. Now, that rules for synthetic division. Now, how to find roots of polynomial equation by using synthetic division? There are these rules are there. That first rule: if sum of all the coefficients in phi of d is equal to 0 is 0, phi of d is equal to 0 is 0. The sum of all the coefficients in auxiliary equation is 0, then d is equal to 1 is the root. This is the first rule. Second rule: if sum of alternate coefficients in phi of d is equal to 0 are equal, means if addition of alternate coefficients in auxiliary equations are equal, then d is equal to minus 1 is the root. Third rule is if d is equal to 1 and d is equal to minus 1 are not the roots, then try by the divisors of the last number, that is constant term. Means you see what is the constant term in the auxiliary equation and you try to find the roots by the divisors of the last number. That is the option. That is the rule, third rule. That fourth rule is if constant term is absent in phi of d is equal to 0, means if constant term is absent in auxiliary equation, then d is equal to 0 is one root of the auxiliary equation. This is the fourth rule. And that one important note is here: synthetic division method is applicable only for finding real roots. So the drawback of synthetic division, we can find the real roots only by using synthetic division. Now the example is here. Suppose d cube minus 7d minus 6 is equal to 0. This is a polynomial equation, and suppose the Example is d cube minus 7d minus 6 into y is equal to 0. Then here the auxiliary equation is d cube plus 0d square. Here the term of d square is absent, so you write down that term 0d square minus 7d minus 6 is equal to 0 is an auxiliary equation. Here means that equation phi of d is equal to 0, then auxiliary equation. Then sum of alternates are equal, that is sum of alternates are equal here means the coefficient of d cube term is 1 and alternate term is first term. After that you think about the coefficient of third term. First term coefficient is 1 and third term coefficient is minus 7. So addition of 1 and minus 7 is minus 6. Okay, now you consider second term and then fourth term. Alternate of second is 4. So the coefficient of second term is 0 and coefficient of fourth term is minus 6. So addition of 0 and minus 6 is minus 6. So addition of alternate terms are equal. First and third term coefficients addition is minus 6. Second and fourth term coefficients addition is minus 6. Means sum of alternate terms coefficients are equal, that is minus 6. Thus d is equal to minus 1 is one of the root of phi of d is equal to 0, means one of the root of this is phi of d is equal to 0. Its root is one of the root is minus 1. Because of this rule that sum of alternate coefficients in phi of d is equal to 0 are equal, then d is equal to minus 1 is the root. We are using this rule here, and so one of the root is d is equal to minus 1. So by synthetic division, now you perform actual synthetic division. You write down the coefficients of polynomial. The coefficient of d cube is 1, so write here 1. Coefficient of d square is 0, so you write here 0. Coefficient of the term d is minus 7, so write here minus 7. Constant term minus 6. Here d square term is absent, still we have written the term using the coefficient 0. So if any term is absent in the polynomial, then you write the term with the coefficient 0, like this example. So we have written all the coefficients here. Now you take one first coefficient as it is 1. Now one of the root here is minus 1. D is equal to minus 1 is one of the root. So you write here minus 1. So this 1 into this minus 1. The multiplication of this 2 is minus 1. So you write here minus 1. Now the addition of these 2 minus 1 plus 0 is minus 1. So you write here minus 1. Again the multiplication of the minus 1 into minus 1 is plus 1. So write here plus 1. So addition of these 2 minus 7 plus 1 is 6. Sorry, minus 7 plus 1 is minus 6. So write here minus 6. Then multiplication of these 2 minus 6 into minus 1 is 6. So write here 6. And then addition of minus 6 plus 6 is 0. So this is the remainder. Remainder is 0 means this considered number is factor. Okay, so minus 1 is one of the factor. Now the degree of the polynomial is here 3. And one of the root of this polynomial is minus 1. So you reduce the degree by 1. So how to write it? Factor is minus 1. So you write d plus 1. Minus 1 is factor, so write d plus 1. And then the second term, these are the coefficients for second term. Now the degree of the equation is reduced by 1. So degree of the equation is now 2. And so the coefficient of d square is 1. Coefficient of d is minus 1. And this is the constant term. And so the equation is here d square minus d minus 6. And one of the coefficient minus 1. So one of the factor d plus 1. And so equate the term equal to 0. So the factors for d square minus d minus 6 is equal to 0. This is a quadratic equation. You know how to find the factors for quadratic equation. This is the formula to find the roots of the quadratic equation. Using this formula, you find out the roots for this equation. D square minus d minus 6 is equal to 0. And the factors are d minus 3, d plus 2. Because minus 3 plus 2 addition is minus 1 and the multiplication is minus 6. So these are the factors: d plus 1, d minus 3, d plus 2 is equal to 0. And if equal to 0, it means it gives d is equal to minus 1, minus 2, and 3 are the roots. Now there are 3 roots and they all are real numbers and distinct, different. So its complementary function is c1 e raised to minus x plus c2 e raised to minus 2x plus c3 e raised to 3x. For every factor you write the separate term because they all are real numbers and they are different, distinct. So there are 3 different terms. Now the order of the differential equation is 3 because this is auxiliary equation is degrees 3. It means the differential equation is of order 3. Why? Because we have discussed the nth order differential equation here. The order of the differential equation is n here. So we have this bracket term c. It is the polynomial expression of degree n. When the order of the differential equation is n, then we have the polynomial of degree n, and this polynomial bracket term is your phi of d. So phi of d is equal to 0 is an auxiliary equation. So the degree of this auxiliary equation is equal to the order of the differential equation here, and that's why here there are 3 factors because the degree of the degree of the polynomial is 3 and degree of polynomial is 3. It means it is the differential equation of order 3. So it has 3 factors and so it contains 3 arbitrary constants c1, c2, c3. The number of arbitrary constants is equal to the order of differential equation. So this criteria is fulfilled here. This is the example. This is one more example. D cube plus 7d square plus 16d plus 10 into y is equal to 0. So you can try for this example. So factors are minus 1, minus 3, plus minus I. You can try to solve it using the same method, synthetic division. You will get your answer. And this is for the complementary function. If the polynomial is in this form, d raised to 4 minus a raised to 4 is equal to 0, then the factors for this polynomial the factors are here. You can write the factors of d raised to 4 minus a raised to 4 as d square minus a square, d square plus a square. The formula a square minus b square is a plus b, a minus b, like that. The factors are here: d square minus a square, d square plus a square is equal to 0. Again, the factors of d square minus a square is d plus a, d minus a. And the factors of d square plus a square, d square plus a square is equal to 0. It means d square is equal to minus a square. Square is a negative number, so the factors for d square plus a square are complex roots. So their roots are plus minus ia, and the factors for d square minus a square are d plus a, d minus a, means at once plus a then minus a. And the factors for this quadratic equation d square plus a square, complex roots plus minus ia. So there are 4 roots: a minus a plus ia minus ia. And so the complementary function is c1 e raised to ax plus c2 e raised to minus x. These are the real roots, first 2 real roots. So write the complementary function for first 2 real roots, and remaining 2 are the complex roots. Here plus minus ia means alpha, your real part of the complex number is 0. So write down e raised to 0 x bracket c3. You start from c3 because c1 c2 is already there. Start from c3 cos 4 sin ax. So this is a complementary function for the 4 roots. 2 roots are real numbers and the remaining 2 are complex roots. And this is for, so here the concept of complementary function is over. Thank you.